No problem.
Hello, everybody. I'm Richard Frovarp. I am a software engineer at a institution south of the border from here. So when I'm talking about SSO, I do kind of bring that perspective, which is going to vary from the commercial perspective of how SSO is used in the enterprise. A lot of it's relatable. And I'll be focusing on the CAS and SAML protocols because those are the ones I know. And luckily, I ran out of time before I had to figure out OIDC. But OIDC is very similar to the components of SSO that we're talking about anyway. What is SSO? SSO most properly stands for single sign-on. It, once upon a time, still perhaps does stand for same sign-on. So you log into your your domain joined Windows machine with a password, and you have to log in something else with that same username and password. That's not single, that's same. Ideally, single sign-on allows the individual to log in once and then access multiple services. And it's great because you can use the technology to hopefully simplify or outsource authentication without even needing to go through multiple services or multiple organizations. The other side of single sign-out is single logout, SLO. It's where you log out of one service and it logs you out of the other services. I'm going to say it's fairly rare. I'm coming at this from a higher ed perspective. Maybe industry has something else to say about this, but I've been in rooms of people, well, this many people in higher ed, and the question of like who has SLO working and one lone hand will go up, and it's not mine. So I'm going to say it's fairly rare, and it can have some negative consequences. So I'm guessing, I didn't test this, but I'm guessing if you log out of like Gmail, it'll log you out of YouTube as well, and that kind of makes sense, and that kind of works. I'm talking higher ed. It's fall. It's late fall right now, right? What are students doing? They're looking at enrolling for classes for next spring. They log into the SIS, the Student Information System. They enroll for their class. They leave the tab open because who closes tabs anymore? They then log into the learning management system with the single sign-on, start taking their test, and the SIS triggers a single logout on a timeout. And it goes through and filters through, and it logs them out of the LMS, the learning management system, as they're taking a test. And tests are frequently set up so that you can only log in and take them once. And they're doing it like today. Now it's probably not bad, but if they do it at 11 p.m., support's not even going to be open. So that's some of the negative consequences I'm talking about, is it can have these unexpected actions, and you can configure things so that it doesn't screw up. But this is like an actual thing I've seen on LMS mailing lists of people complaining about the SIS logging students out of while they're taking tests. So it's something that can happen. There's several components to SSO with all the acronyms, because of course it would have all acronyms, and the terminology varies based off a protocol. So the one acronym is IDP, stands for Identity Provider. In OIDC, it's called OP, and there's a few other things that's called in OIDC. I really do not know OIDC, so don't hold me to any of this. The other side is this SP, the service provider. We'll get into what each of these are in a moment. And the other option is RP, which you will see in the OIDC and the SAML worlds. They'll use relying party as well. And the other kind of key important part of this, of course, is typically the browser. And the IDP and SPs may be from the same organization or different organizations. And these different organizations may not even know about each other. So what's an IDP? It's a system that provides authentication operations. It's what people log into. You can think of a lot of different systems as an IDP, but it only makes sense when you split it apart. If you have a standard WordPress install with a username and passwords in your database, that's providing the identities, right? It's also the service provider, it's kind of all combined. It doesn't make a whole lot of sense to necessarily split them then, but that's what it does. Google and GitHub, and there's other social providers, some with single letters now that people used to use, that you can log into other services with. CAS is frequently used at universities. You run Shibboleth typically, or different SAML things will get behind the, like say, that's part of the Canadian Access Federation, CAF, which can be part of EduGain, which is an international federation of federations. You can have radius servers. There's actually IDP SPs work in the wireless realm. And so you could have a radius server that connects to Eduroam via Canary, which is a Canadian, I don't know what that acronym stands for, but it's the Canadian organizations up here. And it allows people to log into wireless via Radius Federation across different places. And of course, there's Okta, and I think Entra is the new name for Azure AD. I did not fact check that one. And then there's other things. What's a service provider? It's a thing the user wants to use. Most people aren't weird like us and are obsessed about that login form about how can I abuse that thing. So the service provider is the thing that people actually want to use, not the identity provider. So it's Eduroam at another institution. So you could like EduRoom is really kind of cool. It's not really the point of the talk, but it's really kind of cool. So you can take a student from University of Manitoba or University of Winnipeg, and they can go over and they can be like at the Viking Ship Museum in Oslo and log into wireless using their home institution credentials. And so in that case, the Viking Ship Museum would be the service provider because that's what people want to use. There's some commercial providers out there like Zoom or DocuSign or Qualtrics, that sort of thing. There's Orchid, which is common in higher ed. There's Gmail, and then kind of getting to the point of like how you can use this to simplify in your own enterprise. There's YouTube. There's the YouTube app, old TV app, and the YouTube Android app. So why would you want to use these? One of the most common reasons in industry would be to separate your login and your account logic from the rest of your services. Netflix can have one team that focuses on doing login, and then every other team at Netflix can not do that. That's why we use it internally where I'm at. It's easy to write login forms, but like as soon as you want to go through and add in passkeys, you're now updating every single one of your apps. And as soon as you want to go through and do different risk detection, you're updating every single one of them. So you'll basically outsource that problem to the IDP and just let it be taken care of from there. And it can be your own internal IDP that you're doing. So it's not, I'm not saying you have to outsource to Okta or someplace like that. But you just outsource it to a different team. So not everybody has to do everything. In higher ed, we do federated access a lot. I mentioned EduRoam, CAF, EduGain, but you also can see like completely outsourcing to third parties with the login with Google, Facebook, GitHub sort of buttons that you see there. And like I said, you can put a lot of your security policy inside of the identity provider instead of having to move it around apps and then redeploy and constantly update and involve all that sort of thing. And another one that is good, I don't know how much users notice this, to be honest, but it's a consistent login experience. Ideally, our people are only punching in our credentials at places like with our logos on. You can fish stuff, but like hopefully, like that does not put into stupid Weebly forms that we all see phishing happen through. So hopefully it gives people a consistent login experience and they kind of look at that and maybe they even look at the domain and notice the domain and the URL. That's perhaps asking a lot, but it gives them a consistent login experience. So hopefully they're not punching in creds for your organization all over the place. There are a couple different types of federated authentication that comes into SSO. There's bilateral, which is what most people are familiar with. This is where two parties agree to perform federated authentication. It could be a contract. So you could have a contract with Microsoft 365 to come back to your enterprise login or Google Workspaces, your enterprise login. You actually have a bilateral agreement when you sign up to use like sign in with Google. I haven't looked at the terms of the contract. I'm definitely not a lawyer, but like you have some sort of bilateral agreement there. The other option is multilateral. And this is where you just like are part of there's federations, as they say, this is common in higher ed, where you can go through and you can say, well, if people from this institution or this person from this institution can use their home credentials, their home SSO, and log into my service. And so this requires trust. That's kind of one of the big challenges about multilateral federations. It requires trust. And so I've listed a bunch of trust things down there that we have in the higher ed space as far as how we make this happen. We have InCommon baseline expectations. InCommon is a US-based organization. I'm on the board that helps set those baseline expectations. ReFeds is an international organization. I believe it stands for Research and Education Federations. It's like all of us in higher ed working together to set standards. And so they're working on baseline expectations that were taken from ours. There's the MFA profile, again, to where that kind of makes some difference in some sense there. There's assurance profile. How sure are we that Frovarp is Richard Frovarp? Certify, which I cannot remember what that acronym stands for, but it's a method by which we can communicate with each other about security incidents. It stands for like security incident something or other, I don't know. But it's about how we can do that. So if I go through and we see somebody that's logged into our IDP and we know that that account's been compromised and they're logging into, let's say, LIGO or the National Institute of Health or CERN or even Zoom, how do we go through and tell them, hey, we had a compromised account. It logged into your service and I gained access to your data. Once again, I'm not NIH, I'm not LIGO, I'm not CERN, right? How do we go through and securely tell them? And in a trusting method, in a way that hopefully does preserve some privacy and some integrity, I suppose, because I mean, we know that security incidents happen. How do we go through and we properly tell them what's going on? How do they respond back? If they discover somebody's logged into, say, LIGO, how do they tell us that they think that one of our accounts has been compromised? How do they respond back to us? That's what Certify is. It's all like trust and policy. And the National Institute of Health is using basically all of the above to drive their policies and procedures. The NIH provides out granting money to a lot of, it's not just US-based organizations, they provide out tons of health research dollars across the globe. And one of the things that they do is they also have like medical data, right, for researchers to gain access to. Well, they want to make sure it's really that medical researcher gaining access to this data, not someone else. So if we go and look at how SSO works, now we're out of policy, there's a general web flow that this basically holds mostly true for, like I said, CAS, SAML, OIDC. The user hits the service provider, which is either YouTube or Drive or Gmail or whatever it is. The service provider redirects the user over to the IDP. And this by redirects the user means sends the browser, right? So this, in this case, you would go to Google's. And Google might redirect you back to your enterprise, which then starts involving proxies, which are very common in higher ed as well. The user authenticates the IDP in some manner. The IDP directs the user browser to send some sort of information back to the SP. The SP performs some sort of validation, hopefully. And then the user's logged into the system. This is assuming that everything is good and fine. So let's talk about the CAS protocol. This is very specific to higher ed. I don't think it's common outside of it much, but it's a fairly simple protocol as well, so it helps for us to look at it. For the details, there's 3 versions, 1, 2, 3. This can be done by the CAS IDP, the Shibboleth IDP, the simple SAML PHP IDP, plus other ones, and there's PHP CAS, and there's ModAuth CAS, and there's Spring Security can do it. There's a bunch of different ways you can do it. For versions, 1 is old, 2 had a nearly ubiquitous extension, and 3 just adopted that extension. There's also a thing called SAML version 1.1, which is a security assertion markup language. It's the same SAML that you probably know, but it's SAML 1.1 is not that SAML. So let's look at the login flow. And I think there's an OIDC flow that looks very close to this. So the service provider redirects the user to the IDP, and it sticks in CAS's case, it sticks basically the service as a parameter to the URL. So the URL has a parameter on it that says service equals https://eddstate.qualtrics.com. And it sends that on over. The IDP validates that that service is registered or allowed. You could do regex services, so one could foolishly, I would think, say, I'm just going to allow everything HTTPS, and allow that through. The user logs in. There's the ability for a user to do attribute release consent, where they can say, oh, I don't want to release my first name, or I don't want to release my last name, or whatever else it is. That may or may not allow the service to keep working. They might require that information. We are using Kerberos terminology, so we're going to slap a ticket granting ticket, the TGT, into the cookie. This is basically just a session, right, with the IDP. IDP sends the user back to the SP with the service ticket, so it just says, I forgot what the even URL is, but it just basically says, ticket equals st-12345. While this connection is being held open by the browser, the server will then make a separate HTTP, hopefully HTTPS connection back to the IDP and says, I am this, I am Qualtrics, and I have this service ticket. And the IDP will validate that that service ticket belongs to the service and hasn't been used yet to stop you from swapping the tickets around or replaying them. The IDP then on that back channel releases the attributes to the service provider, and then the service provider establishes its own session with the user. For things like CAS and SAML protocols, you basically think of these as swapping out your traditional login form. So after you get it done, you then put in your own session control. This uses one important concept that shows up inside of SSO terminology. This is back channel. I don't remember if that's supposed to be 2 words or 1, but basically it's server-to-server communication, right? The back channel is the SP reaching back to the IDP. This does require that the IDP be reachable by the SP, so you can't have firewalls and everything else in the way of that. So that's one limitation of a back channel communication. But it very much simplifies the payload being sent to the browser, because the browser is now just grabbing this ticket and sending that on over. Attribute return, you can return back the standard ones like first name, last name, email address, entitlements. We can translate identities. My normal username is richard.frovarp, which is mutable, so you can send back different usernames, which is handy. A couple things that the CAS3 protocol does, it can send the SSO login time. We're talking about multiple organizations, so maybe you're not happy with the login time from 12 hours ago. But maybe that's too long ago for your risk profile. There's ways to check it and address that. It also can send back the multi-factor method. Maybe you don't want to use a 30-day remember me cookie. Maybe you want to rely on something that's phishing resistant. You can detect that as well. There's 3 methods to do login with CAS that I'm claiming. There's a few others, but the 3 I'll focus on is one is there's the standard method as described above. And if you have a ticket, granted ticket, or an existing SSO session, the second time you hit an app, it'll just transparently all happen. You just won't be prompted for login. There's one called renew, and this forces authentication. So this is where you go through and you say, that SSO time was from 12 hours ago. I want it within the last hour. Okay, well, how do you get that? Well, you force them to log in now, right? You can pass a flag in there, the renew flag, it forces it in. There is a question of what does this mean for multi-factor? If they're punched in first credential, but then their duo is a 30-day remember me, there is a partial answer to that I'll give you later, but right now it's an And then the other option is there's a gateway option, right? So if it'll bounce people through that entire flow that I described before, but it won't prompt for credentials. It'll just grab an SSO session. And a service that you're used to using probably that matches this idea, it does not use CAS, but this idea is like YouTube, right? You can go to YouTube and you can use YouTube without logging in. But if you're logged into Gmail and you go to YouTube on the same browser, it's gonna opportunistically grab that session. It's not gonna force you to log in. There's a login button if you want to. It's not gonna force you to log in, but it will grab that opportunistically and go on. And that's what a gateway is when it comes to CAS. So let's talk about SAML 2. This is almost always what people mean when they say SAML. It's like the next version of the one the one that kind of really glossed over, but it's way different. The most popular open source project that does this is called Shibboleth. And the word Shibboleth has historical uses as a authentication mechanism where different groups could pronounce it correctly or not. And so it turned you into an in-group or an out-group. So that's why that name exists. So sometimes people will just call this Shibboleth authentication as well, but they're talking SAML 2. This can be done in the Shibboleth IDP, the CAS IDP, the simple SAML PHP IDP, the 3 I just last named, right? A lot of these identity providers in open source world can go through and talk multiple protocols because it just makes life easy. Okta and others can do that as well. The feature support varies by IDP. The 3 above are very good. Ones like Okta and Entra and stuff are not ADFS, in my opinion, because I have fancy multilateral federation requirements. On the SP side, there is something called the Shibboleth SP. It runs a daemon called shibd, and this has various integration in modules into HBD, Nginx, and IIS. And how that one works is it just keeps injecting the headers, and ModOff CAS does the same thing, and there's an OIDC one that does this too. But basically, the web server will keep injecting your authentication details. So keep injecting first name Richard, first name Richard, first name Richard on every single request that goes through. It's behind these modules, and your browser can just, not your browser, sorry, your software can just go through and look at basically the headers and see if your person's allowed through or not. One advantage of using these modules is you can protect just like flat file directories without having to throw like a PHP proxy in or a Spring or whatever proxy you want to throw in to actually just force authentication to serve up a JPEG or a PDF or something like that. You can just use shibd, or ModOff CAS, or like this mod OIDC, all for like Nginx and HBD. We do a lot of like multilateral federation. So there's a thing called WAIF. Where are you from? Places that you've probably seen this is, who all does this? DocuSign does this, Adobe does this, Microsoft does this, Google. Your first login bit is your username, and it's grabbing your domain and figuring out if it needs to redirect you back off to an enterprise login. That's a where are you from discovery mechanism. We have a lot of extensions for SAML 2 in higher ed. And I'm going to say it has some unique security challenges. It's old. The protocol's from 2005. And I have a couple dates, years down there, just to kind of help remind some of us old people how old that old is. The Arab Spring was in 2010. That's when there was protests and revolts in many places, including in Libya. And I distinctly remember from this time period that there was concern because people were organizing these, I'm going to call them protests, for lack of a better word, via Facebook Messenger. And there was a concern that the Libyan government was going to go through and do a man in the middle and intercept these messages and do bad things to these people, right? And so I remember Facebook like rushing out to put HTTPS in front of stuff because in 2010, we were not putting HTTPS in front of everything, right? This is like insane now. Glitchwich was talking about strict transport security earlier by just forcing everything so that it works in HTTPS. We weren't using it for most anything at all back then. And I remember Facebook like rushing and putting TLS certs in front. And it was like, well, The Libyan government actually has a trusted CA, so they could have still man in the middle and put their own CA for Facebook.com in there. And then we have Edward Snowden's disclosures in 2013 about talking about intercepting, once again, unencrypted communication. So some of the security challenges of how it looks and works is because it was trying to address problems that from a world where we weren't encrypting traffic. And it has front channel, which I'll go into in a moment. So the SAML2 login flow. Once again, these all look fairly similar. The SP redirects the user to the IDP. This time we include a SAML payload. What's a SAML payload? It's an XML document that's being published. Key in this XML document is the entity ID, which I'll get into what that is, but it basically identifies the service. Assertion consumer service URL, ACS URL, where to send the user back to. This payload can be optionally encrypted because we're running on a non-HTTPS world from 2005, and it can be signed. The IDP looks up the SP metadata, which is an XML document typically, to make sure that it's valid to be communicated with. The user authenticates, optional attribute release consent. An SSO session cookie is created. We're no longer calling it the TGT because we're not copying Kerberos terminology, but we can create a SSO session. The IDP creates a SAML payload. It can be optionally encrypted using the SP's public key from metadata because, once again, we're in a 2005 world. This doesn't happen much really anymore. The next thing is it can sign it using its private key, which really should happen. The IDP redirects the browser to post this XML blob back to the SP's ACS URL. And then the SP should validate that the signed payload is valid with the IDP's public key that it has from its copy of the metadata. And then the SP will then start its own user session with the user. One security issue is you could not validate the ACS URL. There's an ACS URL that comes in from the post that I talked about. There's one inside the metadata. You should probably make sure that those line up. I think you can have multiple ACS URLs for different methods and different endpoints inside your metadata, and so you should make sure at least one of them matches. Ideally, you're running a system that, like libraries that just take care of this for you, right? I talked front channel. Burp Suite. So front channel, let's talk about this real quick. Front channel, I'll get to my slides basically out of order, is that the browser is transporting all the data from the IDP to the SP. So it's user-provided data. If it's user-provided data, we can screw with it, we can mess with it, we can have fun with it. So this is why IDPs should be signing the payload, and SPs should be validating that the payload is correct, the signature is correct. So Burp Suite can do everything, and it has a plugin called SAMLrator. And I think this is a truncated chunk of output of XML because it's awfully short for this sort of thing. It's definitely missing a signature, and I believe I deleted that off because it just keeps scrolling. But this is kind of what it looks like. We can see that it has Frovarp at ndsu.edu. There's, I don't know if my mouse is showing up. Nope, not really. But it has a not on or after, and it's going to educause is what I was logging into. Now, I could swap that out and claim I'm Mike.Saunders at ndsu.edu. He's not part of our institution, but I could just drop his name in to see what happens. I'm picking on him because he's speaking next. But like I could swap that on out, or I could try richard.frovarp at uwinnipeg.ca and see what happens. Well, hopefully you're validating that signature and not getting, the service provider is validating that signature that's being provided, is truncated off of here, and so that you can't go through and do it. But I know there's a lot of SPs out there that aren't going to be validating that signature, and that's something you need to be testing as you deploy this stuff and you want to validate. There are front channel communication mechanisms with OIDC as well, and I think a couple of those are deprecated now because it is a problem. I keep talking about this metadata thing. What is it? It's typically an XML document. That's what my familiarity is with it. It contains a few different pieces. It contains an entity ID. This is just a string. I think by spec it has to be URN in almost all our URLs. But it should be something in your namespace and something you control. Third-party vendors, cloud providers, SSO providers don't let you do this. But if it's yourcompany.okta.com, when you want to move to someplace else, you're not going to be able to grab that bring that okta.com with you, right? If you want to go move over to Microsoft, they're not going to let you assert an entity ID of okta.com. So it should be something in your namespace. Once again, there's vendors out there that don't let you do this, which causes problems in the higher ed space. Another key component of this is there's X509 certs. And the whole point of having an X509 cert is just a way to go through and I think it's base 64 encode well, basically it's, you've all seen X509 certs, well, most of you have. It's just a way to put a public key in there, right? It's like the cert parts kind of don't really matter. It's the fact that there's a public key in there. And so it's a method of encoding and transporting the public key in the metadata. So please do not make these TLS certs. These should not be TLS certs that go back to a public CA. You should not be getting these from GlobalSign or Let's Encrypt or whoever, right? These are just a way to transport the public key. If you're having them rotate every 2 years, it's a pain in the ass. I had to rotate one of ours with something that was integrated about, I don't know, 50, 60 times. We did have one fail, and this was through a system that was supposed to actually really handle it well. So go self-sign with long-lived. If you need to rotate earlier, rotate earlier. And then also inside the metadata, you can include different extensions for different data. Some of these are better or less supported. Some of these might be core, I don't remember. But you can put security contact information for that certify problem, right? I talked about before, if you discover something's been compromised. You can put in entity categories, which I'll get into in a moment. You can put in support context, error URL, if one of my users has a hard time, run into a difficulty of logging into somebody's thing because they opted out of providing their email address, let's say, it'll send back to me and put up, because I'm an IDP operator, it'll put up an error to contact basically our help desk. You can say which requested URL attributes you want to have. There's privacy policy URL, so before people log in, I can say, here's the privacy policy of the thing you're trying to log into, because it could be a random service off in Germany that we have no connection with that's set up to help grad students out somehow. And put your logo URLs, because everybody likes logos to be put up. Some of the enhancements for SAML in higher ed is that we do large-scale federation. There's one service provider, it's a wiki, that allows like 6,000 different institutions to log into it. So when I say large scale, that's how higher ed rolls. The authentication context request, we actually have a method that we've added so that you can go through, and I think it's part of the core spec, but we've standardized on it, to go through and say we require multi-factor to happen, because organizations are very different spots in their migration to multi-factor across the globe, and we can say, yeah, if you're going to access this service, we require multi-factor to happen. Something that's just part of core SAML is forced authentication. So the same thing I said back for CAS, like I want a new authentication. I don't want to trust anything that's old. So then back to my question of, well, what does this mean for MFA with the 30-day remember me on Duo? Well, if you are conforming and applying and requesting whatever, refeds MFA 1.2, which is not quite yet ratified, but that has the very specification in there. It says, if I am doing a forced authentication and I'm asking for multi-factor, I expect it to happen. It doesn't have to be strong right now. You can still do Duo pushes and text messages, but you can't do a 4-hour remember me. Maybe you can do a 4-hour remember, but you can't do like a 30-day remember me on a Duo or something like that. We want this to happen a lot quicker. A couple other things that you can do. This is, like I said, a SAML feature, but you can do this in a data providers period. When you federate with people, is we have entity categories that are rolling out now in higher ed. The 3 categories are anonymous, pseudonymous, and it used to be called anonymous, but people didn't know what anonymous meant, so it's called personalized. I didn't know anonymous wasn't a word until they said that, and then I'm like, you know what, that kind of makes sense. With this anonymous and pseudonymous thing, there must be something going on there. So anonymous is where people log in and you don't say who logged in. It's an anonymous login, which sounds kind of crazy from, I'm sure, a lot of your perspectives, but this comes from a couple different places. One is the temperature in the EU is very much privacy focused. And in the other temperature in the United States is that I think the Patriot Act lets you subpoena off people's library records, which libraries don't like that. I'm not sure what the temperature is up here. But the idea is that we won't do privacy preserving. So if you're logging into a library and you're only accessing online resources, physical books mean something different because you can walk away with those, right? But if you're logging in and getting access to an online resource, or you're logging into journals, do they really need to know who you are, right? Maybe not. If they're coming in from an institution and the institution says they're permitted to get in under our license, do they need to know who they are? The answer is probably no. The next option is pseudonymous, which is still they don't know who they are, but every time you log in, you're given the same basically fake username with that service. What does that allow? Well, it means you can favorite your favorite journal articles, that sort of thing, right? But both of these stop 2 different service providers from 2 different publishers, let's say, 2 different journals, from playing Go Fish with users as well, right? They can't say, well, do you have Jeff? Yes, I got Jeff. That's going to match. Or do I have Katie? Yes, I've got Katie. And now you can start going through and maybe correlating where we don't want people to be correlating from a privacy-preserving point of view. So that's the advantage of anonymous and pseudonymous, and personalized is sending, you know, full email address and stuff like that. They're all very valuable. One of the great attacks against SAML, it's called Golden SAML. This is for SAML 2.0. If you can get a hold of the IDP's private key, you basically have the whole, you have the whole game, right? If you can get that private key, you can generate any payload you want, you can sign it, and the SP will validate it. Hopefully it still catches like domain swaps. You could only use it for the one domain, but you could log in as root.institution.edu or .ca or whatever like that. And one of the problems is that since this is all front channel, there's nothing that ever goes back to the IDP. So the IDP is never told that this person logged in. It just happens. And so it's impossible to detect a golden SAML attack at the IDP side. If you have access to the SP, which I don't have access to this grad helping software over in Germany, right? I don't have access to them. I don't even know who they are. I just looked through logs and randomly saw it. But like, I can't do correlation. If you can do correlation between stuff, you could detect this. But if you can't do correlation, you can't detect it. Unlike the golden, I'm trying to remember my stuff because I'm not a domain admin, but there's the golden ticket that eventually will time out and talk back to the DC. And perhaps you could detect that then. But this one, there's nothing that comes back to the IDP. One piece of notion when it comes to trust is that the IDPs can say really whatever they want to the SP. Like I said, it comes down to trust. It comes down to being a good actor. So the ISP puts a lot of trust into the IDPs because the IDPs release whether or not MFA happened. I can lie. My bottom bullet point is I can lie. There was one institution that was asserting that if Duo wasn't available, but the person would have duoed, they could still assert that multi-factor happened. And there was kind of a loophole in the spec around that one, and so the spec's been patched. As far as the trust framework, it's like, no, if they didn't do multi-factor, then you cannot claim that they did multi-factor. I can swap out usernames. You might not be able to do this in an Okta or something like that with like a CAS or a shibboleth. Like in CAS, when I configure releasing of attributes, I typically just say release whatever I got in the directory. We use AD in our case, but I can put in not JavaScript. I can put in Groovy, and I can just write whatever I want. I could say if I see Richard.Frovarp, swap out and replace somebody else's name so I can become somebody more powerful. My account has a ton of access, so there's not many others, but like I could swap mine out, and so you need to trust all this sort of stuff. Some capabilities that the IDP can do is you can rename attributes. So you can easily just swap things out so mail becomes email. You can replace them with something less mutable. I've got mine set up to always lowercase the usernames because I got tired of seeing usernames in different casing. I can modify attributes. I can filter what attributes are being released so I don't need to release all of my entitlements to all of my third parties. We can also, from a security point of view, on the IDP side, we can go through and we can say, oh, is this person allowed to even go on out to, say, Zoom or Qualtrics or wherever else like that? We can filter on the IDP side and make it so the SP doesn't have to do it, or maybe the SP does it as well. It's kind of you can go either direction with it, depending on what you want to do. But that is a way you can add some more security on top of stuff. A couple of other ways to attack the IDPs. If you can get onto the system, you can examine memory, and you can probably see a lot of creds, a lot of beginning parts of creds. The CAS IDP, the shibboleth IDP, and Keycloak are all, which I don't know really anything about Keycloak, but it's an IDP. They're all Java-based, and Java likes to keep strings sitting around in memory a lot, so you can potentially, you might not be able to correlate between things, but you probably can simplify your search space and get your password stuffing on down. You can also use like an unsecured Tomcat manager, just load a payload next to the IDP that's running in there, and away you go if it's a Java-based one. With CAS now, people are running it via like an embedded Tomcat or embedded Jetty. Shibboleth is best run with a Jetty, and Keycloak is via WebSphere, I think. So there's potential ways to abuse the underlying systems that are running this. And then as soon as you can see creds from there, you can get in and do bad things. I don't know if this is a IDP or attack or not, because I really haven't thought about much, but I believe it was the HAR archives, right, from Okta, where they're getting in and they're basically grabbing those session cookies with the IDP, or they could have grabbed session cookies for anything, right, because they grabbed all the session cookies. But if you can get to the session cookies and grab them, you potentially could go through and it's not so much an IDP attack, but it's attacking the user and using the IDP to further out your attack. Depending upon how your stuff's deployed, stuff's a lot better at this now, so hopefully you're keeping, your IDPs, by the way, are of course security products, right? They should be kept up to date. You shouldn't be running CAS 3 or something like that, that was from like 8 years ago. Stuff has changed and been updated since then, but if you don't have ubiquitous MFA, you have to make sure that your step-ups actually happen, so you hit a low. The issue here is that the person hits a low risk system where you're not forcing MFA on the person, and then they go to hit a high risk one, making sure that, yeah, they pushed in username and password, but I need to step them up, making sure that happens would be a good thing to test. I haven't had to deal with it because we just say, if you're logging in, you're doing multi-factor no matter what. This is kind of this one maybe doesn't apply quite so much anymore if you've updated stuff, but the legacy Duo web integration, which they are moving off of, like that ends like next summer, all that responded back was that yes, the person got past Duo. So that Duo web integration did not really say anything. So depending on how your integration was configured in Duo, it said the same thing whether the person was using phishing resistant MFA or if they weren't registered for Duo and they were not required to register or do anything past that, and they were just allowing people pass because you were doing bypass for people that weren't registered. It said the exact same damn thing. And so you really couldn't tell. So you need to make sure when you put these systems together that you actually know, this is very specifically the integration with Duo, but you need to make sure that you understand what it's saying back. And then in my case, if you're asserting it out to third parties randomly, you need to make sure that you're actually not asserting multi-factor out to a party that really cares about it, like NIH, when it didn't happen because you allowed a bypass. The new Duo method tells you what MFA method was done, so you know whether it was phishing resistant or weaker. So that was a kind of a whirlwind overview of a lot of it. There's some other protocols out there that are worth definitely mentioning. There's ad hoc. Just please don't do it. Just please don't. Like, there's standards out there. They're actually good standards. OIDC is a good standard. OAuth's a good standard. Like, do those. This is years ago, but I looked at one and went, what's my browser sending from this login? And it was like, oh, my employee number, without any signature or anything else off to the parking system. I'm like, well, that's not great. Ask somebody else, and I tried it with a different number. I got clearance to do that, tried it with a different number, and yeah, I got into theirs. It's like, that's not great. And some institutions are like using that to like scan license plates and do parking and stuff like that. And you could do like kind of scary stalking and harassment because people could get in that way. There's an older one called WSFed. I'm going to call it kind of a pain, and seems to be really only supported by Microsoft. It is like an Oasis standard, I think, but yeah, it's basically Microsoft. One of the cool things about WSFed is that if you log into like Microsoft 365 and you're doing this via WSFed, I punch in richard.frovarp at us.edu in that case, and it goes, okay, well, I know where to send you to the enterprise login. And when I get to the enterprise login, it punches in my username that I punched in before. That is because WSFed actually has the ability to forward that username on. So that's a cool feature about WSFed. If you're using a password manager, which you should be using password managers, it's just going to fill it in for you, so you don't have to retype your username and password. Well, you have to retype your username. There was a thing called OpenID. I don't know if it really ever was used all that much. That was kind of like a roll your own, bring your own identity provider sort of thing. So you'd log into random stuff and you punch in the URL of like your WordPress instance, and I can't remember who all else would support it. And you could log in with that. So it was like a very much a, like one of the terms that's coming around for other things these days is like self-sovereign identity. Basically, you could log in with your own creds to other places. So it's like this federation that I've worked with in higher ed, but like with no trust baked into it. The good one, one of the good ones on this list is OAuth 2. It allows the IDP to issue an authorization token to a third party, to make API calls. You need to secure the different tokens. There's different flows through there. The one good example I saw of that is, as said, I'm not from here, so I went and got my card, and so the IDP would be the person at the front desk of the hotel. My token is my key card, and the SP is my door. And the door doesn't need to know who I am at all. It just needs to know that I'm allowed into that hotel room. And so that's how OAuth works. If you need to know who the person is, and there's different audiences, and once again, I'm not good at this at all, but that's what OIDC is. And so OIDC sits on top of OAuth. It is OAuth, but it has the ability to actually send actual user information as well. OIDC, I don't remember why they took OpenID, because I don't think it's actually a successor to OpenID, but the OpenID Connect is very much different from the original OpenID. And there's a YouTube video there. It has it's from, well, it is from Okta, about how OAuth and OIDC work and the different flows. And if you watch that video, which I did the other night to try to refresh my memory on some of this stuff, they talk about the front channel, they talk about whether or not stuff's being passed and which parties are involved. A lot of stuff I've been talking about today, but way more specific to OAuth and OIDC. That's my whirlwind tour of SSO. Do people have questions? And I do see a hand, I see a hand behind Mike, right there. So the question is, with all these protocols and all these different places, how do you know what they're doing in the back end, right? And whether or not you need to get a certificate was from is the. Yeah, so whether or not you get the list of what they're doing. Yeah, that is something you want to do for your enterprise, especially if it's your bilateral agreements will definitely have that. Multilateral federation across the institutions, you're kind of going, well, here's what my risk profile is, and you're relying on the trust. I'm relying on the fact that CAF trusts the University of Winnipeg, and InCommon, where I'm at, trusts CAF, and so therefore we go. It's a very much, in this higher ed stuff, it's very much a web of trust, that people are actually bothering to pay attention to the standards correctly. The SPs are the ones that actually have a lot of risk in here. So the question is how do we go through and detect and defend against man-in-the-middle attacks on multi-factor authentication? And yeah, that's a problem. One of the things that we're trying to go through and define in the community is like, what is strong authentication? NIST is doing some work around that as well. And the question is, do you just do hardware tokens? And yeah, the answer basically comes back to there's two types of hardware tokens. But if you use like the standard normal consumer available hardware tokens, you are phishing resistant, which is the key thing that man-in-the-middle or phishing are the two things we care about. So a YubiKey and a passkey use. Passkeys are getting really weird because of like what Apple wants to do and stuff like that. I barely understand it, but it's getting a little weird. But if you can just like a YubiKey and you plug it in and you hit it, that is resistant so long as the attacker can't get to DNS. If the attacker can get to DNS, they can somehow screw with those, which happened at a bank. There's a person that's like writes all these standards, that's talked about this at a conference. So I'm like repeating what he said from my memory, okay? So, but basically if you can go through and you can get to DNS, you can compromise those tokens. If you're using the full FIPS tokens, then that's DNS shenanigans resistance as well. Question over here, yeah.
At the University of Manitoba, we use Google as well.
Okay.
What sort of rationale is there for splitting off your MFA provider from your IDP instance? Because
Okay, so the question is, why do you split your IDP and your multi-factor provider, given that Microsoft 365 and Duo both are multi-factor providers that can also do identity provider stuff? It's a good question. Those two are not going to be good at multilateral federation with EduGain, and so that is one of the things. There are ways to proxy. Basically, you can create a proxy just for that particular use case, and you take your rest of your use cases. And if you have the multilateral federation, which he's also at a university, so he has multilateral federation concerns likely. So yeah, that's why you would want to split them. The other thing is that some of those don't let you bring your entity IDs with you. And I know that places in higher ed, we're sensitive, everybody's sensitive to prices, but I think we're sensitive to prices in higher ed, and so if Duo jacks up your costs, it's probably easier just to move, and it's just a question slide, it's probably easier to move just your multi-factor instead of your entire identity provider. And then also in our case, we're provisioning all of our most interesting bits of data about our users to our AD, so that's kept local, which is different from a Duo perspective. I answered your question well enough? I know it's almost evading, but okay. Ideally, long term, I would like to do passkeys, and so our people just log in. If you do the new passkeys, you can log in with basically the key, and then some sort of either PIN or biometrics, and so people don't have to punch in using password, or doing another multi-factor run, and you just log in just with basically a thumbprint, and you can log into stuff, which is what people were seeing. I know a lot of you in industry, but like that's what we're seeing from these different apps, right? On the phone is that people are logging in with just their thumbprints or your face IDs, and students are going to be expecting that from us in higher ed. So be good and be able to start supporting that. The other bit that I didn't cover at all, that I understand even way, way less, is there's the whole verifiable credentials and self-sovereign identity. We're starting to see that in the United States, in places like Colorado with digital driver's licenses. There's a whole spec on there. And in that case, I know that the plan is for the 50 states plus I'm guessing the 5 territories in DC to actually have like 50 some odd bilateral trusts to be able, so the police can go through and check to see if I go into Minnesota, the police from Minnesota can see if my digital driver's license is actually valid in North Dakota. There's a lot of different interesting challenges around verifiable credentials and digital wallets that are being worked on right now. I don't know if that exactly is SSO or not, but it is a way of asserting identity from one party to another. Any other questions?
Yeah, so one of the platforms we use at work is, like, we're heavy Veeam, right? So Veeam Service Provider Console allows for MFA, but only if you're a non-SSO user. How would you protect, like, the SSO, like, sign-on? Like, if you're signing on to, like, Microsoft 365 as a SSO, how do you protect on top of that?
Protect on top of what? I'm right. Missing the question, sorry.
Okay, so the SP,
mm-hmm.
the IDP and SP would be Veeam Service Provider Console to
yep.
Office 365. But if you're using local logon to the Veeam console,
yep.
it provides MFA.
Right.
But because Veeam doesn't fully service or like acknowledge Microsoft, it's in a documentation. It's not fully supported yet.
Okay.
How would you protect like the SSO logons? Like if the SP doesn't have that baked in for an SSO?
I'm not entirely sure, to be honest. That comes down to your agreements and your trust and that sort of thing, as to whether or not how much you trust the IDP to be actually doing what it says it is. Okay, thank you very much.